Okay, so linear regression. So we did some last time. Again, we'll do one now. Okay, just for practice. Linear regression. Linear regression. Okay. So it's a simple linear regression. So under this, so we have x variable, y variable. X is an independent variable. So independent variable means I'm taking as Nifty, the market. Okay. And dependent variable, you take any other company, let's say TCS. Now, when Nifty is giving 12 percentage, TCS is giving 8. When Nifty is giving 10 percentage, TCS is giving uh, also let's say 9 percentage. When Nifty is giving minus 2 percentage, TCS is giving 1 percentage return. Okay, and Nifty is giving, let's say, 8 percentage, and TCS is giving 9 percentage return. Fine. Okay, so this is the given condition, given data. On this basis, we have to calculate R. R means correlation. Then we have to calculate R square, and then we have to calculate SEE, sum of the standard error of the estimate. Okay, standard error of the estimate. What is this? We will see. Standard error of the estimate. Okay, and then n is equal to 1, 2, 3, 4. That's it. So this is what we have to find out. Apart from this, we also have to find out the ANOVA table. ANOVA stands for analysis of variance. Analysis of variance. Okay, ANOVA table. ANOVA table. Okay. 1 minute. Just hold on 1 minute. Yeah, so ANOVA table, that is analysis of variance. Now
Yes.
in this table, we have to calculate degree of freedom, then sum of the squared. Okay, this is sum of the squared. Then MS, then mean sum of the squared. Then F test. So here, this is, you're also writing, right, along with me.
Yes, sir.
This is regression, which is also called as explained variation, not variance. Okay, it is variation. So what is this variation also we'll see. The next one is error. This R and E is important here. Okay, why it is important you will come to know later. Error, and this is unexplained variation. Okay, then next one is total. Okay,
Okay.
yeah, so this is what we need to calculate all this. Okay, you have written till here. This is
Yes.
the question. Okay, based on this given condition x and y, we have to calculate all the other variables. Okay, so first of all, r is equal to covariance of x comma y divided by standard deviation of x into standard deviation of y. So covariance of x comma y, how do we get it? So covariance, so I'll come here, r is equal to covariance of x comma y. Okay, so probably I can write again this. Okay, I'll do one thing. I'll write here. I don't have to scroll up down again. So this is x variable nifty, and this is y variable TCS. So nifty is 1210 minus 28. 1210 minus 28. And TCS is 8919. 8919. Okay. So now covariance of x comma y is equal to, not covariance, r is equal to covariance divided by standard deviation of x into standard deviation of y. So now for covariance, summation of x minus x bar into y minus y bar divided by n minus 1. So x bar and y bar we require. So you calculate x bar and y bar now.
X bar is 7
7,
and Y bar 6.75.
6.75. Okay, now you use the Calci method also, so that we don't go wrong anywhere. So you go to Calci, and in your calculator you type this one, second 7, right? and then x variable is what? 12. So 12, enter, downward arrow, y variable is 8, enter, downward arrow, x2 is 10, enter, y2 is 9, enter, then x3 is 8, no, minus 2, enter, and then y03 is 1, enter, x04 is 8, enter, y04 is 9, enter. Okay, then we want the output, so we need to activate this stats function. So second and then 8, okay, so that the upper function stats gets activated. Then lean, go to downward arrow, 4, x bar is 7, you got 7, x bar,
Yes.
here 7, y bar is 6.7, y bar is here 6.75, 6.75 we are got. Okay, so we will keep coming here and we'll keep checking this. Okay,
Okay.
then now x minus x bar into y minus y bar. So x minus x bar into y minus y bar. X minus x bar is, this is 12 minus 7. So I'll write this first. Now x bar is 7, 7, 7, 7 into y is 8, 9, 1, 9. Y bar is 6.75. So calculate now. 5, keep 5, as store 1. Then calculate this one, store 2, and then multiply. Or if you think this calculation and storing is little difficult, what you do is, you can just simply do, you can calculate all this and keep storing it. Then again calculate all this and keep storing it.
Okay.
And then you do 1 and say, for example, this is 1, 2, 3, 4. Store 1, 2, 3, 4. This is 5, 6, 7, 8. Then you do 1 into 5, and then again you store it as store 1. Then 2 into 6, store it as store 2. 3 into 7, store it as store 3. 4 into, so you do slowly this way so that there is no human error. Or because now, otherwise, because now we know how it is supposed to be done, we know we require standard deviation of x also. What you can do is further, because last time when I was doing, it was first time I was doing this sum. Otherwise, in front of you, first time I was doing this sum. Otherwise, if I have to do, what I will do, I know that I will require x minus x bar the whole square later
Yes.
in standard deviation of x. So instead of doing all these things, how I would do is, I would simply say x minus x bar only. I will calculate only this much. Okay. So that will come to what? X minus x bar is 12 minus 7. See this way how I am doing, which is equal to, so then that human error all will not happen then. 5. 10 minus 7. 3. minus 2 minus 7 equal to minus 9. 8 minus 7 equal to 1. This is x minus x bar. Okay, then y minus y bar. So y minus y bar, 1 minus 6 point, so 1 9 1 9 6.75.
So the first one is 8 minus 6.7.
Is it 8? Acha, this is 8. Okay. Sorry. 8. Okay. Yeah. So you are calculating now, right? All this.
Yes.
Just calculate and tell me the number.
Okay. $67.
1 minute. Overall, you have calculated. No,
Yes.
what is this? 8 minus 6.75?
1.25.
1.25.
2.25
2.25.
minus 5.75. 2.25.
This is also 2.25.
Yes.
So now summation of x minus x bar into y minus y bar. So now you multiply these two.
6.25. 6.75. 51.75. 2.25.
Okay. So yeah, now you add up all this.
67.
67. So we have got this 67 divided by 4 minus 1.
22.33.
22.33. So this is a positive number. That means there is positive core. They both are moving in the same direction. That much you can say. Okay. So 22.33. Standard deviation of x. So standard deviation of x is root of summation of x minus x bar the whole square divided by n minus 1. So I know x minus x bar already. So I just have to square it. So summation of x minus x bar the square is equal to. So first one is 25.
Yeah.
Second one is 9. This one. Second one is 9. Third one is 81. Fourth one is 1. Okay. Add up all this.
One one six.
Okay, 116. So this is equal to root of 116 divided by 4 minus 1. Just calculate this.
6.218.
Okay, standard deviation of x. Similarly, now standard deviation of y. So standard deviation of x is 6.218. Now standard deviation of y. Summation of y minus y bar the whole square divided by n minus 1. Okay. So y minus y bar the whole square we know. Right? Y minus y bar. So y minus summation of y minus y bar the whole square. So square all this 1.25 square is what?
1.56.
1.56. 2.25 square
5.06.
minus 5.75 square
33.06.
then 2.25 square the same one, no? 5.06. Now you add all this.
$44.7. 3.86.
3.86.
86.
So 3.86. Now you calculate all this.
0.930.
Okay, now we'll see in the calculator also. Where is the calculator? I think I missed it. I closed by mistake, seems. Did I close it? Okay, I'll have to then again type all.
Sir, I have the values.
Huh. Um, okay, I'll also quickly just upload it,
Okay.
okay, so that I can see here as well. Okay. So second 7, 12, 8, 12, enter, 8, enter, x2 is 10, 9, 10, 9, enter, 9, enter, again -2, 1. So -2 and then 1, 8 and 9, 9. Then second 8, 7, we got 7 here. Then standard deviation of x is 6.22. Did we get 6.22?
Yes, sir.
Acha, correlation
6.218.
na? 6 point, yeah, standard deviation is 6.218, which is fine. Then this is population standard deviation, we don't require. Y bar is 6.75, also correct only, right?
Yeah. Yeah.
Yeah, that is also fine. Standard deviation of y 3.86.
Yes.
This is perfect. Then population standard deviation of y we don't require. Intercept and slope we will check later. R is equal to 0.93. Okay, so that means we have done correctly. 0.93 till here it is all fine, right? So
Yes.
actually we could have done like this so quickly here.
Yeah.
Okay, so but this all this long cut is just to understand the background work. Okay.
Okay.
Yeah. Now further next step is R square. Okay, so R square, simple formula is you just square it 0.93 square, but you will not get so easily in the exam. Okay, there are other formulas also. Calculate this R square.
0.864.
0.86. Okay, fine. So now, uh, understanding equation of a line. So this is how. So equation of a line will be a plus bx. Okay, it is also written as y is equal to b0 plus b1 x1. Okay, y and x. Okay. Uh, yeah. Okay, so this is the equation of a line. Now this is the regression line. Okay, the regression line. How are we getting this? This is the line drawn exactly in between. Okay, and then yeah. So we are drawing the line exactly in between. Okay, it is regression line. Okay. Now this is called y bar. Okay, and this is called y hat, which we have to find out predicted value of y, and this is the actual y. Okay, now first of all we have to calculate the value of beta and intercept. Okay, so based on this equation I can say y bar is equal to a plus b x bar, and beta's formula is, okay, beta is equal to covariance by variance. Covariance of what? Covariance of market comma stock divided by variance of stock. So covariance of market and stock is 22.33, correct?
Yes.
22.33. Variance of the stock, I mean variance of the market. Market is X, right? So 6.212 square it. 6.218 square it.
38.66.
38.66. Okay, how much is this coming to then?
0.577.
0.577.
77.
Okay, that is the beta. So we have got beta and we know x bar, y bar. What is y bar?
6.75.
6.75, right?
Yes.
Equal to a plus 0.577 into x bar is how much? X bar
7.
7. So now calculate the value of a.
2.71.
2.71. Okay, which we can cross check now. Go to the calculator and do the cross checking. A is 2.71, correct, and B is 0.58. That is also correct.
Yes.
Okay. Huh. Okay. Then huh. Okay. So I know A's value, B's value, and X bar, Y bar. So now on this basis, I can calculate the predicted value. See the predicted value is equal to A plus B X. This is the formula. So predicted value for the first one is A is 2.71 plus B is 0.577 into X1's value is
12.
is it 12?
Yes.
Okay. 12, 10 minus 2, 8. So 12, 10 minus 2, 8. I'll just shortly write here. 12, 10 minus 2, 8. Okay. So 12. So how much should it come to calculate?
So should I tell the final value?
No, individually you say we have to cross check with the Kelsey, right?
First is 9.63.
9.63, because we don't require the total of all this. We
Okay.
require individually. Second one,
8.48.
huh,
1.55.
huh.
7.32.
So you use Kelsey like shortcut method, or you just manually calculated it?
Manually.
Huh. So we'll now cross check with Kelsey. Okay. I think here it doesn't work, this one. So here you can check X bar is 12. So 12, enter, downward arrow, Y, compute. Yeah, it is not working. You check now.
X bar 12 and then Y.
And then when you get Y, you will get 0, right? Click on
Yes.
compute.
Yeah, 9.63.
Now again you do down upward arrow, go to X dash. Again you type 10 over there.
Okay.
Okay, 10.
8.48. Yeah.
10, enter, downward arrow, then again compute, you will get 8.48. Then again you do upward arrow,
Yeah.
go to -2, type -2, enter, downward arrow.
1.55. Yeah.
All these are matching. Now last one also you check.
7.32. Yes.
So all these are fine, right? So now I need to know uh, this. This is called what? Explained variation. Okay, not variance, variation. That means I'm going to square this. Okay, so y bar minus y hat square is explained variation, right?
Yeah.
And this part is unexplained variation, which is y hat minus y the whole square. Now it doesn't matter whether you are taking y hat first or y first, or here y hat first or y bar first, because you are squaring it up. Okay,
Okay.
and this total is y minus y bar the whole square. This is total variation,
Yeah.
which we have already calculated here. Y minus y bar the whole square, we have already calculated here. Total variation.
Yes.
Is it okay? Fine.
Yes.
So now, yeah, so I have to calculate explained variation, that is y bar minus y hat. So I'll calculate here y bar minus y hat the whole square, which is explained variation. Y bar is what? Y bar is
6.75.
okay. And y hat is 9.63, 8.48, 1.55, 7.32. Now you calculate this. Now we want only the total, but still you keep telling me the number
Okay.
individually also.
First one is 8.29.
Ah,
Second 2.99.
ah.
27.04.
Hmm.
0.324.
Hmm.
38.65.
This is explained variation, y bar minus y hat the whole square. Okay. Then unexplained variation is what? Unexplained is y hat minus y, direct y, not y bar, actual y. So y hat is, okay, here 9.63, 8.48, 1.55, 7.32. Y's value is 8919. 8919 square. First one
5.61.
Hmm.
0.27. 0.3025. 2.82.
This is unexplained variation.
9.0122.
Okay. So now you add these two, explained and unexplained. That should match with total. Add these two.
47.6.
44.7. So still 2, 3. Numbers are differing. Slight difference somewhere. Some small mistake somewhere happened. Y bar is 6.75 only, right?
Yes.
8919. Okay. Okay. Just quickly calculate again this one.
Okay.
Just one by one, you just quickly recheck.
Sir, explained variation is correct. I'll check the other one.
Okay.
So the first one, y hat minus y square,
Hmm.
it's 2.65, the first one.
This is wrong.
Yeah.
2.65.
Yes.
Now that means what is the right number here?
6.04.
Now it should match. Add up.
Yeah, 44.6.
44.7. So that is
Yeah.
fine. Okay. So now we have to just plug in the number. Degree of freedom is always k. For level 1, it is always equal to 1. K means number of independent variable. Okay. So for level 1, there will be only one variable. Then this is n minus k minus 1. That means n minus 1 minus 1. So therefore, it will always be n minus 2. So in our case, it is 4 minus 2 equal to 2. Okay. Then, so this is 1 and 2 equal to 3. Then sum of the squared regression, SSR. So that's why this R is important, SSR. So SSR means explained variation. Okay, explained variation is what? Explained variation is y bar minus y hat the whole square. That is explained variation, right? Here. This part. Y bar minus y hat the whole square. Which comes to what? Which comes to
38.65.
38.65. Then SSE, error. That means unexplained variation. What is that? It will be y hat minus y the whole square.
6.04.
And this total comes to 44.6 or 7, right?
Yes.
44.7. Okay. Then next MSR will always be equal to SSR, okay, because the denominator is 1. So the formula is what? MSR is equal to SSR divided by degree of freedom. So that is equal to SSR is 38.65 divided by degree of freedom is 1. So 38.65. Okay. Then MSE is SSE divided by degree of freedom. So SSE is 6.04 divided by 2. Just calculate this.
3.02.
Now F test formula is MSR by MSE. Okay, that is equal to MSR means, this again further I can elaborate as what? Y bar minus y hat the whole square divided by degree of freedom. So y bar minus y hat the whole square. 1 minute. Y bar minus y hat the whole square divided by degree of freedom. Degree of freedom is 1 whole upon this. Also I can write as 1 minute. Just 1 minute. Huh. Uh, di- Divided by MSE. Acha, SSE I can write as y hat minus y the whole square divided by degree of freedom. So similarly here also uh, y hat minus y the whole square divided by degree of freedom is 2. So this is degree of freedom, degree of freedom. MSR is
38.65.
38.65 divided by 1. Okay, whole upon 3.02 divided
No, 6.04 divided by 2.
6.04 divided by 2. Okay, so this is very similar to variance by variance only. Okay, variance by variance. So finally, how much is it coming to?
12.79.
12.79. Okay, so 12.79. Now I will check this. Okay, so null will be no change in variance. Null is equal to 0. That means variance variances are not significantly different. Variances, that means no connection between them. Variances are not significantly different. Alternative is not equal to 0. That means variances are significantly different. Variances are significantly different. So now I'll check the table. So numerator is on the top row, so 1. So I have to see top row 1. Okay, and denominator is 2 on the side row, so 2, 18.5. So 18.5 is the critical value. And what is the one that we have got? 12.79. It is falling within the range. So that means there is no difference. It is not variances are not significantly different. Okay, variances are not significantly different. Okay, variances are not significantly different. So this is the outcome. Okay, then here the other formulas are explained variation divided by total variation. So explained variation is how much? 38 something, no?
38.65.
And total variation was 44. How much?
44.7.
Yes. Is it coming to 0.86?
Yeah, 0.86.
Okay. Otherwise, I can also find, say, like 1 minus unexplained variation divided by total variation. 1 minus unexplained variation is how much?
6.04.
Divided by 44.7.
Right, 0.6.
Hmm.
0.86.
Huh. Okay. So see, this also can be written as total variation minus unexplained variation, which gives what? Explained variation. We can write like this also. It all will give you the same answer.
Okay.
Understood? These are all
Yes.
see different ways. You should know all because you don't know how they are going to confuse you.
Yeah.
Okay. So like for example, this also will give you the same answer, right? This will be 44.7 minus unexplained is 6.05 divided by 44.7. That will give you 38.65 divided by 44.7. It is
0.86.
just this number finally.
Yes.
Okay. Then standard error of estimate is the standard deviation of the entire model here. So that is equal to root of MSE errors root. Okay, because when we take the root, we'll get standard deviation. So MSE means what? MSE as in MSE is this part. Okay, y hat minus y the whole square, y hat minus y the whole square divided by degree of freedom. Okay, so this is what this is now standard deviation. I'm taking the root. This is in the form of variance. So root of MSE 3.02. Calculate
1.73.
1.73. Okay. Actually, we would prefer where significant, variance significantly differ. But then, okay, because our sample is not very good, we are taking only 4 observations. Okay, fine. Okay, now is this okay till here?
Yes, sir.
Should I show that Excel also again?
Yes, sir.
Okay. See, after practicing this, you start reading. You will be able to understand maximum things in that linear regression. Okay, then what I will do is I will just go through the doubts. I will be going through page by page also. But if I
Okay.
directly take you through, you will feel like, left out then. So
Okay.
you read it once because then it will be all be easy only, theory only it will be. Okay. The when you look at the readings, it will all be the articulation of whatever we have done over here. Okay.
Okay, sir.
Nifty is X variable and TCS is Y variable. So this is the only given information. So I'll select this number, go to data analysis, then regression. Okay. Then Y range. So Y is this number. So it will select this range. Then X range is Nifty. Then that's it. Then output. If you just leave it like this, it will create a new Excel sheet and there it will show the output. If you want the output on the same page, oops. I'll close this. Output range, click here. Anywhere you click, from there the answer will begin. Click on OK.
Okay.
That's it. Something went wrong. I'll just redo. Selected this, so that's it. This is regressions. Y variable is this much. X variable is this much. And output range is this one. So we can cross check the numbers. See, the system has automatically calculated p-value.
Yes.
Okay. So you don't have to calculate it anywhere. This part, at the moment, it's not required though. Okay. All this, but till here it is okay. If you understand, till here it is all fine. Okay. Adjusted R square is not for you, so you can ignore that also. Okay. It is there in level 2. Level 2 continues from here only. It starts from here.
Okay.
Okay, fine.
Yes, sir.
Hello.
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 Hello. Hello.
Can you hear?
Yes, sir.
Okay. Okay, you understood till here. It's all fine.
Yes. Yeah.
Okay. Okay, I'll stop then. Okay.
Yeah. Yes, sir.
Okay then. Okay, bye.
Okay, sir. Thank you,
That's
sir.
it.
Bye, sir.
Bye.